All right, we're back. We're on page 5, notes 18. We're talking about average value of a function, average value, integral over interval. If you can remember that, you can solve any of these problems. I believe in you. Just got to know the fundamental theorem. So I'm pretty sure I wrote page 5 when I realized after doing the notes one year that like all of the average values that I gave in here are basically positive. That doesn't need to be true. I mean, what if a function exclusively has negative y values? Then the average y value would have to be negative. So let's do this one where I guess you now know that you're definitely going to come up with a negative average value, but given this function, graph the function. You always want to review your trig graphs. They can save you a lot of time. So here we have a sinusoidal axis of -1. Like I'm going to dot in. I don't think we really need to, but I can go up to and I can go down to. The period of this thing is going to be 2 pi. So the period is 2 pi divided by pi over 2, the coefficient of x. So it's 4, which makes the increment be 4 over 4, which is 1. So we're going to start. It's sine. It's positive sine. We can go up here, here, here. Keep messing up. There, and then we also have to go back because I mean we're graphing the whole thing. So here to here to here to here, and then let me try to sketch this in. Doop, doop. You want to do like a little piece at a time. Then if you're slick and you're on an iPad, I suppose what you can do is you could like duplicate this. This seems like how am I gonna like? Hold on. I'm trying to duplicate, like, I think this might work. No, I didn't get the, oh, because well, it kind of worked. It would be easier to draw this. But you gotta, when you get technology, you gotta play around with it. Okay, there we go. That's our sine curve. Now, we want the average value on the interval from -2 to 0. So -2 to 0, the integral is gonna be like this. Definitely a negative integral. So since the integral is negative, the integral divided by the interval is going to be negative, and so we're going to get a negative average value. So let's do it. So we want the integral from -2 to 0 of the quantity sine 2 sine pi over 2x minus 1 over 0 minus -2. So that's going to be 1/2, right? So that's from 1 over b minus a. Let's integrate. So there should be pi over 2, so 2 over pi, so 4, but negative. -4 over pi cosine of pi over 2x minus x from -2 to 0. This is going to be a weird average value. Is it going to be a weird average value? I mean, it's going to be, I don't have a guess. I mean, I was going to guess it's like -1. -1 feels like it should be a part of the average value because it's a sine curve and like, like it hangs on -1, so it feels like that should be there. I don't know. So 1/2. All right, when I plug in 0, the cosine of 0 is 1, so I get -4 over pi minus 0. And then minus, when I plug in -2, I get the cosine of negative pi, which is the same as the cosine of pi. So that's a -1. So I get -1 times -4 over pi is positive 4 over pi. I think I did that right. And then plus 2. Okay, so that's 1/2. And you just kind of like simplify however you're the most comfortable. So I am, I guess, most comfortable just messing around with it as I simplify. I don't have like a super organized way of doing it. Oh, okay, so there, yeah, maybe. I got -4 over pi minus 1. So that -1 is kind of a part of it. How weird is that pi that I drew? It's like I don't know. Let's go back to the drawing board. There we go. -1 minus 4 over pi. What relation does this bear to our curve? I mean, the -1 makes sense to me, and then the -4 over pi. I don't know. I'm sure like if I paid attention to trends, I would know how to like modify the average value of a trig function at this point in my life. But I'm thinking more likely I will never know because, I don't. So if you were to dot it in, -1, and then -4/pi is like another, it's more than another -1. So you're kind of like here. Does that feel right? That feels right. Right. I mean, like, maybe more than that feels more right, but I don't know. That's probably about it, I think. I feel like it needs to actually be like lower because, well, -4, yeah, it's like -1.3-ish, maybe. I don't know. Yeah, around there. If only calculators existed and we could work it out. Find all possible values of C. Oh man, such that f of C is the average value. This is too much trig. I'm going to use a calculator on this one. When we do this in class, we will do it by hand. Honestly, it is way, way harder than the AP exam would require you to do. So it's going to be 2 sine of pi over 2x minus 1 equals. Let's see how much we can do. I mean, we could just do it by hand. We get this, right? Okay, not bad. Add 1 to both sides, fine. Divide by 2, fine. We get sine pi over 2x is -2/pi. Now you're in like this math analysis zone where you got to think like it's sine and it's negative, so we can come from quadrant 3 or quadrant 4. Then, because we're solving in 3 and 4, we're going to have to subtract a period from the answers that we get because we don't want like these answers, which would be in quadrants 3 and 4. We want these answers. A lot going on there. So it's going to be like inverse sine. I don't know. It's going to be like pi plus the inverse sine of 2/pi and then times 2/pi. So 2/pi quantity pi plus inverse sine of 2/pi. Then you're going to subtract the period. So I don't know. I'm just going to do it on the calculator. Let's go to the calculator. So I'm going to define the function. F of x is 2 times sine of pi over 2x minus 1. Okay, so let's just check the average value. Integral f of x -2 to 0 over 0 minus -2. Almost got that wrong. Okay, so that is -1 minus 4/pi. Awesome. Solve. F of x equals that answer for x. Let's just limit it. So control equals 1 to the left. -2. Control equals less than x less than 0. I'm just going to type it. And we're in radians, so if we solve it, so we get this. I'm just going to get decimals. Ew, okay. I'm going to turn these into decimals and just write them down. So x is approximately 3 decimals, -1.561, or x is approximately, and I'm now realizing I should have said C, 439. 439. So let's go back. Let's go back to the notes and see what we wrote. Those should really have been C values. I try to like stress that a lot. I don't, unless somebody's really a jerk when they're grading you, I don't think you're gonna like lose your, I don't think you're gonna lose points for that. But like technically, therefore, C is approximately -1.561 or -0.439. Because sometimes I am the guy who is the jerk, right? So don't leave it up to the person who's grading it. Like if you're supposed to solve for C, even though like x is obviously the value that you meant. Write the equation line tangent at x equals -2. So f of x is a pain in the neck. And I keep needing it. Like I should have just copied and pasted it into each part of the problem because we've needed it everywhere. So f of -2 is 2 times the sine of negative pi minus 1. The sine of pi is 0, so negative 1. Also, I could have just looked at the graph. That probably would have been a good idea. F prime of x. So chain rule. So we're going to get 2, and then there's a pi over 2. So it's pi cosine pi over 2x. And then the derivative of negative 1 is 0. So f prime of negative 2 is pi times the cosine of negative pi. Cosine of negative pi is negative 1, so negative pi. Gross tangent line, but that's all right. Tangent line. I mean, actually, it's kind of neat. Like, when do you get a slope of negative pi, you know? Y plus 1 equals negative pi x minus negative 2, so plus 2. Okay, let's just check that derivative in our head one more time. So it's 2 times, chain rule gives you a pi over 2, so that's going to give you the pi. Derivative sign is cosine pi over 2x. Yeah, I think that's right. All right, and then there's this question, unrelated. Given that the average, okay, so we're given the average value is 14. So 14 is the average value of, so the integral from negative 3 to 5 of f of x dx. Just take the info that you're given and write down what you know, right? 5 minus negative 3 is going to be 14. So what do we know from that? We know the integral from negative 3 to 5 of f of x dx is 14 times 8, which is 80 plus 32. 112. 112. Okay, so we know the integral. What is the value of the integral from negative 3 to 5 of f of x over 6 dx? These questions, like, they're always doable. You just have to figure out, like, how does what I was just told relate to, like, what I can find? So I know that this value, right, we just found this. This is this. So this is going to be equal to 1/6 of 112. Which is, I don't know, they're both divisible 56 over 3. I think that's all the simplifying you can do. You could actually leave it on the AP exam as 112 over 6. I hate that. Like, if I'm the one who's going to ultimately be grading it, you should be simplifying things. But on the AP exam, when there's a time crunch, you know, maybe you leave that. Maybe you're not sure if you're going to simplify it correctly, whatever. Do the safest thing. I'm always advocating for that. But for me, the safest thing, because you know I will mark it wrong if you don't simplify it, is to simplify it. So all right, I'm going to end this video here. I will be back in the next one. And it looks like we're going to be doing some old AP questions. 1978, are you kidding me? How old? But anyway, I will see you then.